it's my pleasure to open the third event in the show and tell series. I can see a lot of yes responses. Thanks, guys. And this time we're presenting companies from LocalGlobe portfolio, and these are 5 amazing growth stage companies. And one of the things I'm particularly proud of and happy with is that we were able to significantly increase the diversity. So you're gonna see people who come from different ethnical background. You're gonna see people who are gonna. We have our first or second female engineer presenting on the conference. We have people who have kids and who don't have kids. We have people from the UK and from outside of the UK. So that's great. And for us at TechTree, diversity is a really important point. And before I start introducing the first speakers, I wanted to take 2 minutes to briefly mention our big focus and a new launch. So one of the things we're going to be launching from November is going to be a mentoring platform. So we're going to have some amazing mentors who are people coming from diverse backgrounds, whether it's ethnical background, female engineers, etc., who are very successful engineers from companies like Google, Palantir, Skype, founders who have exited their businesses. One of them was actually backed by LocalGlobe, and they're all technical, and they're gonna be doing mentoring. So if you're interested in becoming a mentor, let us know. My colleague Sam will post. Have already posted a brief information about mentors. If you're interested in being mentored, please also sign up. And what we hope this platform will help people to do is help to get the jobs they deserve by their merit, not thanks to their credentials. Because I think a big challenge for many engineers we have spoken to over the past years, especially coming from diverse backgrounds, was getting access to great mentors and opportunities. And the first company that's going to be presenting is going to be first presentation led by 2 people. It's going to be Tessian. Tessian is an amazing fast growth company. There are already about 60 engineers. They're looking to grow, to double the team. So Krzysztof and Michael will talk about what's exciting for them at Tessian, and let's give them a warm round of virtual applause. And I hope that you guys can join the stage. Great. So over to you, Krzysztof and Michael. Tell us what are you particularly excited about and what you're working on at Tessian.
Cool. Thank you very much. Does that work? I hope so. Yeah, thank you. Thank you very much to TechTree for having us. I'm Krzysztof, and we also have Michael.
Hi.
And we're software engineers at Tessian, and we're very excited to tell you about Tessian and some technical challenges that we solved that we thought you could find interesting. So the core mission of Tessian is to protect businesses against threats on email, and particularly those threats that come from a human error. So the principal belief of Tessian is that humans make mistakes, that you can come up with all sorts of policies and training for your employees, but sooner or later someone is going to do something wrong. And we should use technology to assist humans and protect them and the businesses. So what kind of threats are we talking about? A big one is when someone accidentally sends an email to the wrong person. So imagine you want to share some confidential documentation with your colleague, but instead you send it to a journalist who happens to have a very similar name. And that's a real story, by the way, that happened to a company. So Tessian tries to detect that and warn the user before it's too late. Another threat type that is a huge problem for enterprises is phishing and highly targeted spear phishing attacks, where the attacker, for example, tries to impersonate someone at the company. And these messages can look very convincing. And honestly, I wouldn't expect any human to be able to always spot these. But I think technology has a good chance to do that. So the Tessian platform protects against these and other threats. And it also allows administrators at the company to have oversight and let them understand the kinds of risk that their business is facing. Okay, maybe let's jump into the more technical side of Tessian. I'm sure you will be interested to hear about that. You can think of our architecture a bit like this. So we have some elements that integrate with the email infrastructure of our customers. So for example, it can be through an email gateway that intercepts all email traffic. And then we have some services that perform classification of emails. For example, for outbound emails, it would be to determine whether it's misaddressed or not. And we have some services that use all the email traffic that we see to keep our models up to date so that we have a good understanding of the relationships between email users. And most our backend services are written in Python, and we host them on Amazon Web Services. Okay, so let's look at the big box that says data store. It actually does get a bit more complicated than that. So this is actually multiple data stores that use different technologies. And some big ones for us are Postgres and Amazon S3. And inside each of them, the data is separated by tenant. So what do we mean by tenant? Tenants are our customers. So it could be a big bank or a small law firm. And we say that our systems are multi-tenanted because they're used by multiple tenants at the same time. So these services, they can handle requests for any tenant equally well. They don't care. But it's important that the data stays separated. We hold very sensitive customer data, so any mix-up could be really bad. So doing things this way has many operational advantages. We can very easily onboard tenants. And look at this example. Look at this example of a service. We only ran 14 copies of this service, but each of these copies is able to handle requests for any of the hundreds of customers that we have. And this allows us to handle thousands of requests every minute. But multi-tenancy requires care. As I mentioned, we need to make sure that the data ends up in the right place. And perhaps you can think, well, how hard can this be? If, say, each tenant has their own folder, we just need to make sure that we include the right folder name in all the code that needs to have access to it. And sure, we can say that we are going to try to remember to do this in all the right places, but engineers are humans, and humans do make mistakes. And I want to say this is not to put blame on anyone. At Tessian, we believe in blameless culture. So when something goes wrong, we focus on looking for improvements to our processes. But yeah, bad stuff is going to happen. And it happens to the best of us. So this really isn't a multi-tenancy issue, but I think from the technical point of view, it's probably very similar. So basically, Google, earlier this year, they had an issue when they stored private videos in archives of the wrong users. So what can we do to reduce this risk? Well, here we have some ideas. So we can create abstractions that make application code simpler and easier to reason about. And we also should have multiple safety nets. So we like to talk about the rule of 2 mistakes. So we never want to be a single bug away from a major data issue. There has to be a few things that go wrong. So with that, I'm now going to hand over to Michael, who's going to tell you some bits more about how we implemented these ideas in practice.
Cool, excellent. Thanks, Krzysztof. Hopefully you can see my screen. So, yeah, as Krzysztof mentioned, in this kind of second half of the talk, I'm going to talk about Tessian's approach to solving some of these issues, and specifically, I want to address this this issue on the slide. That is, how can we keep the operational advantages of multi-tenancy that Krzysztof mentioned, but reduce the risks to an acceptable level? And at Tessian, we think that a reasonable approach to this problem is to make a multi-tenanted environment look single-tenanted to applications. And to do this, we've invented an abstraction that we like to call resources. And to talk you through resources, what they are and how you might use them, I'm gonna go through a simple example. So imagine that you've got some app that is part of your services backend, and it's going to receive some HTTP requests that are going to be associated with some tenant, and it's going to have to perform the business logic that it was created to do. And as part of that, it's going to have to access these two data stores that I've called D1 and D2. Now, this is obviously a very high-level example. So to make it slightly more specific or realistic, we might add this in. So here we're indicating that each of these data stores, as Krzysztof mentioned earlier, holds data for lots of different tenants. So now this application is really having to do two things. It's having to first select the correct tenant's data from the data stores, and then also operate on it to perform that custom business logic. And ideally, we'd like to separate out these two concerns in the code. And that's exactly what resources are designed to do. So you can see here that the business logic never talks directly to any of the data stores. It goes through a resource. So in this example, the business logic might call a method on one of the resources to say, get a file from the data store. And then that resource would go and get that file from the data store, but automatically for the correct tenant. So the business logic doesn't need to be concerned with that. Now, one very obvious question you might have with this diagram is how do the resources know which tenant they're meant to be targeting? And to enable this, there's actually a kind of a second component, which is what I've termed here this request parsing layer. So requests come into this layer, they're parsed and sent through to this custom business logic. But crucially, this layer also pulls out the tenant that the request is associated with and gives this information along to the resources so they know which tenants to be targeting in the data store. Now, this is, or should I say, that this custom business logic now doesn't have to be concerned with tenants at all. All the code that's concerned with which tenant we're operating on is these blue boxes, which make up part of the kind of framework, if you will. So I would say that by and large, we've achieved that goal of that first slide that I had of making this multi-tenanted environment look single-tenanted to this custom business logic. So this is how it looks from kind of a diagram point of view. But what about some actual code? So this is what implementing this might look like in code. I don't want to go through any of the specific details here, but what I wanted to highlight is that I hope you'll agree that this code is relatively simple. And that was important to us because having a simple interface for this framework means less bugs when people use it, and also increased adoption across the company, both of which were important to us when designing this resource implementation. So now I'd like to take a moment just to kind of do a slightly more deep dive on how we might create one of these resources. And specifically, I want to look at S3. So for anyone who isn't aware, S3 is an AWS managed key value store where the keys are path-like, or at least it's good enough to think of it like that for this presentation. Now, one of the first things we need to ask ourselves when designing one of these resources is how are we going to separate our tenant data in this store? And I think for S3, a very reasonable approach is to have the tenant ID as the first component of any key. So just to run through a quick example, let's say we have our S3 resource and we've got a method on it that will allow us to ask for all keys that start with a certain prefix. And let's say we use this method to ask for all keys that start with the prefix foo. The resource will then do some work and make a request to S3, asking for all keys that start with this prefix. S3 will then hopefully fulfill our request and respond to us. Let's say it responds with these two keys, and then the resource will process this response and pass these two keys out. So essentially what's happening is we're prepending tenant IDs to requests to S3, and we're stripping them from the responses. Now, this looks like a reasonable solution that at first glance you think, yeah, this would work, but maybe there are some problems with it. So if we stick with our same setup, but now instead of asking for the prefix foo, we ask for a prefix that looks like this, and then we perform the same logic as before, we end up making a request to S3 for this prefix, which in some cases, it is possible S3 might interpret like this, which is obviously really bad because we've now broken our tenant separation. And I don't think the exact problem is important here. The point I wanted to highlight was that even for this very simple resource, doing this tenant separation isn't completely trivial. Now, to help us avoid some of these problems, in many of our resources we've built at Tessian, we've used another AWS service called STS. Now, I'm not going to go into the full details of the service here, but essentially STS allows us to dynamically create credentials with a certain set of permissions. So in this example, we would use credentials that only allow us to operate on keys that start with the correct tenant ID. That way, if this error occurred and S3 did interpret this request as the key /5/foo, then S3 itself will reject the request because we wouldn't have permissions. And this goes back to what Krzysztof was saying about having multiple safety nets. Both the resource itself and S3 provide protection against any issues. Now, I'd just like to finish up by quickly mentioning some of the compromises the framework makes. It's not perfect, as nothing is, and I think there are a couple of notable things. So firstly, we incur a little bit of extra latency for STS. To get these dynamic credentials, we have to make requests to Amazon, and that takes a non-zero amount of time. Secondly, some storage technologies are hard to abstract into a resource. As kind of a rule of thumb, the more complicated the interface the technology provides, the harder it will be to abstract in this way. And then lastly, it's less flexible than an ad hoc approach. As with any framework, when using it, you have to align with the opinions of the framework, and that's certainly true here as well. So with that, I'd like to thank you very much for listening. Also, if any of that sounded interesting, we are hiring, and I believe there are links to our careers pages somewhere around here, or maybe a link you've been sent. Thanks very much.
Thank you.
Let me invite the next Mofe. Hi, Mofe. Do you hear me?
Hi, Powell. Can you hear me?
Yeah, absolutely.
Awesome.
So Mofe is a developer advocate at Yapily, a company representing one of the most exciting sectors in London, so fintech, and he's going to talk about what Yapily is doing around open banking. So Mofe, over to you.
Awesome, thank you. So with any luck, you guys can see my screen, but I'm just going to continue. So hi everyone, my name is Mofe Salami. I'm a developer advocate at Yapily. And today I'm going to be talking to you about some of the challenges that we're solving as an open banking gateway that's integrating across UK, Ireland, and Europe. So today this talk is going to be mainly focused on our main microservice, which is the Yapily API. But we do have a range of different microservices, both front end and back end. And so for the purpose of this talk, I'm going to focus on our Java microservice, Java Spring microservice. Our stack is built on the Duke Cloud. So we use GKE to deploy our services as containers, using Helm as a deployment mechanism, which is of course built into our build pipelines. But then for the Java API, we have a Swagger specification that allows us to build Java, Python, and Node SDKs, which will be versioned across every time we do a release. We do multiple releases a week using, of course, the agile methodologies. But we don't actually have a versioned API. So one of the approaches that we took from the start was to have a backwards compatible API. And this is going to be a really interesting problem, or a really interesting thing to bear in mind when we start speaking about some of the challenges. For those of you who are not familiar with open banking, it basically gives you the ability as a third-party provider to communicate with a bank via their open APIs for open banking. And it gives you the ability to access a user's account information and to initiate a payment on their behalf just by actually going through the OAuth 2 flow and requesting consent from the bank. And so these screenshots that you see here are something that a third party, such as Wardo in this example, would actually use and build. And then they'll use the API requests that you see at the top. So get institutions, post create account authorization, and get accounts to actually access that information. So some of the things that Yapily provide, so in the second screenshot here, we give you a list of all the different names that the bank may use. So the short names, the full names, as well as icons, and various other information that will allow the developer to build the application that they want. You then have to show the mandated requirements and the consent screen to show the customer exactly what you're requesting for them. And then once the user confirms that they're happy to share this information or initiate this particular payment, Yapily will actually provide a means for you to generate an auth URL to send your user to via redirect, which will redirect them to the bank. And that could be on the web, or that can be on the mobile app if you're using online banking on your phone. And then the user will be able to see the exact same request within the bank and authorize it. Providing they do that, then you'll be issued the bank will issue a token to Yapily, and Yapily will take care of exchanging that and abstracting that for you as a consent token, which you can then use to get accounts, transactions, and any other use case that your application may you may desire to do. And so you can use that link at the bottom there to see a more detailed overview of some of the examples that we have, along with the various different requests and at what stage you want to do that. So without further ado, let's start looking at some of the challenges that we're actually addressing. So from the inception of the company in 2017, one of the big things we wanted to do is come into the open banking space and really provide a unified way of communicating with each of the banks. So that will be in the request and the response, the request to the bank and the response you get back from the bank. So as you can see on the screen here, on the left, we have everything you would have had to do for every single bank if you want to connect to them. And this is an example taken from when you want to create an account authorization. And this is actually one of two requests that you actually have to send on behalf of Monzo. So of course, you have to learn all the various different headers that you need to provide, as well as the URL for the bank as well, and for the particular endpoint. And of course, over time, you also have to take on that maintenance work to keep up to date with the banks. And obviously, if you're doing this for every single bank and you're looking to onboard across many different countries, that might be a lot to actually do. And so what we provide is an abstraction that hides all of this complex, all the security, all of that from the customer. And all you have to supply is an institution ID and the user who is actually requesting or whose information you're either requesting or initiating a payment on behalf of. So great, problem solved, right? Well, we found that this worked quite well initially, but as we began to increase our coverage across Europe, and as we began to onboard more and more customers, we actually found that the functionality provided by each of the banks will be quite different. And that's kind of to do with where open banking is today, in the sense that there's a lot of space for optional pieces of functionality that is up to the bank whether they want to provide or not. And so we had to kind of tackle how we wanted to support that and of course make that available to our customers. So a very simple way we did this was by breaking down all the different things you can do with a bank, such as getting the account information into what we call a feature. And all this would be just a description of what you can do and can't do with a bank. And this, of course, allowed us to go on a bank by bank case and tell you exactly what you can and can't do with a bank. And we provided this information in our Get Institutions endpoint, which you saw in that those series of screenshots of the mobile application. And we found that this was actually quite useful for actually managing change to an existing bank. So with the example of when a particular feature from a particular bank was found to be unhealthy, maybe it was down, or maybe not working as intended, this gave us the flexibility to turn off that particular feature behind the scenes and not expose that to our customers. And this would be a change that we can do without actually breaking any of the features or any of the functionality within the API. So that was quite nice. It also meant it gave us the flexibility to actually be able to turn on those features or make those features available just by providing these flags as the banks actually mature and continue to support newer features that weren't currently supported. And again, doing that without actually breaking any of existing banks' behavior or existing customers' behavior. So amazing, right? It's a great solution. This works and solves 2 of our problems already. Well, actually, we do have this kind of other problem that we now have to onboard and think about when we actually had a new feature that Yapily hasn't already tracked or kept a record of in its list of supported features. A good use case of this is what happens when we integrate a bank and it actually doesn't fit in with any of the other features that we currently have supported. How do we actually cater for that? And actually, when you begin to think about this a bit more, we realize we may actually have a deeper problem here. And sometimes we're in a position where we have to include a new feature that is not currently employed or not currently implemented within the Yapily API that may actually cause a break-in change to the API. Because as I mentioned, Yapily is a backwards compatible API, but the client code and the client SDKs are versioned. And so for statically typed languages like Java or C#, for any customer who is reading these list of enums, these features that are supported, if they see a new enum, that will actually break their code. And how do we manage that and the fact that sometimes we need to include a new, or sometimes we need to be mindful of some of the customers' release cycles. For example, customer that we actually have, or one of the customers we actually have, can only release every 6 months, but there might be a feature that is breaking if we don't bring it in. And so a lot of these problems are really because of open banking and because of it's a new space and because depending on where you are situated in the world, the specifications are actually implemented quite differently. So within the UK, it's quite good. It's quite consistent across a lot of the banks. But within Europe, however, a lot of the banks have a lot of flexibility to interpret the bank behavior slightly differently, and interpret the way the bank should behave in different ways. And so this is a big problem that we are in the process of solving. And one of the ideas we've had would be to change the way in which we expose these features to the customers. But it is a big and global change because it affects every single customer and every single bank. So one of the ways we've solved this in the short term is by actually keeping a track of all the different changes that we're making and working with customers on a one-to-one basis in terms of the change that we're making, and just checking and aiding them through how to upgrade and the changes to make and when those are coming. And so a big change and a big example of this was when we had the two account features here. So get accounts and account and accounts. And in the UK, that actually provides you access to a user's balances as well. However, we found that within the CBI Globe gateway, so a lot of the banks in Europe, which are connected through this another gateway, they actually split balances and accounts. And so account and accounts was no longer an effective way of describing or was not a consistent way of describing the information that you get back from the API. And so we had to include two new features, account without balance and account balances to get those balances. So moving on to the penultimate challenge, how do we actually handle different bank behavior? So this is no longer focusing on what feature is provided, but the same data, how is that actually treated by the bank? And a good example of this is actually when making payments and the reference that you can use. And so we found that with particular banks within the UK, the reference has to be less than 18 characters. And if it's not, the payment will actually fail. With other banks, and we've actually seen this with, for example, Monzo, the reference will actually be truncated at 18 characters. So if the user specifies a reference longer, that will be cut short and the payment will actually go through. And then with other banks, and we've seen this mostly within Europe, the reference can be more than 18 characters, and that will be the reference seen on the transaction as well. And so now, based on all of this information, what should be the default documentation for this reference property? And this is just one small example of a problem that we have to solve quite a lot within open banking and within Yapily. For this particular problem, we've just decided to tackle the lowest common denominator, and that would be just to say document, and that will be just the document that we only support or we advise that customers should only use a reference less than 18 characters or less than or equal to 18 characters. And this is mainly to prevent a lot of if-else cases, and as many customers will be using banks across many regions, and so one solution for all is a much better fit. But one other thing that we noticed that was actually a lot more important was actually the way we handled our errors. And so this first screenshot that we see here on the top was how we displayed our errors a few months ago. And we would just return a generic error code of 424 and a failed dependency, and we'll give a tracing ID, which they could raise with support in order to find out more information. Well, all support would be doing would be checking the logs and seeing the exact same error message that we see in that second screenshot. And so because, of course, we're a startup and we want to scale, we want to build on more customers, we just had to provide this information to our customers to make sure that we weren't hammering the support department. And so this is a big change that we thought was really useful for addressing these types of problems. In a similar kind of vein, we also provided an optional feature on all of our endpoints to expose the raw request such that customers can see exactly what we're sending to the banks and get more information when things do go wrong. And then also they can see how Yapily is normalizing a lot of the requests and the responses that they get back from the bank, and have complete transparency to see what Yapily is and isn't doing. So my very final challenge is how do we actually manage bank downtime? And this is a really crucial problem to solve, as obviously as an API gateway, if a particular bank is down, that will cause errors with the Yapily API, and customers will be angry at us if they're not aware that actually the problem's with the bank. So internally, one of the ways we did this was actually by looking at the bank's downtime and pulling in that data into Slack, and so we'll be notified when there's actually big issues. Similarly, we also built a dedicated monitoring solution that we actually provided for OBIE. So that's the open banking implementation entity, but then also we've now made that available to our customers. And so they can see key information and the historical data of when things were down, and also get live information of our bots pinging or each of these endpoints to see if there are current issues, and then also pulling information to see, again, the planned events from the banks. Another kind of solution, another kind of initiative that we had quite recently was actually an API score, which was our ranking of the banks, as a way of motivating them to actually improve their integrations and incentivizing them to do that. And we've actually had a couple banks actually reach out to us and say, hey, how do we go higher on this score? But I'll say the most important thing that we've done, which our customers really benefit from, is actually exposing the monitoring data direct through the API. And this gives the customer the ability to see and to programmatically build in flows to actually show banks that are only healthy or not support features that are broken with the banks. And then also being able to toggle off different banks based on whether they're healthy or not as well. And so this has been a real good solution to actually tackle this. So that's my talk. Some of the key takeaways I'll say is definitely think about the data structures. If we had to do this all again, if we had known the state of how the banks were implementing a lot of these regulation, then we wouldn't have chosen to use enums in the same way. Another big part would be to enable developers to self-help where possible. So this is through providing examples, providing those error messages, and giving monitoring ability to see the raw request. Just free up the developer to help themselves as much as possible. And this is critical as a startup to actually scale, as we're not going to have all the time in the world to deal with every single request that a customer could, or every single error that a customer could encounter. And then finally, as I've shown in that second or third slide, would be to use working examples over documentation. And one nice kind of example of this was actually how we used to onboard customers. We used to do post-run demos to show how to implement each of the endpoints. But what we actually found that was a bit more effective was having a mix between interactive documentation. So this is screenshots of what the customer's application will actually look like, along with the different endpoints that they can call. And we found that that really helps, especially when working in a space like Open Bank, which is quite new and not everybody understands. With that said, that's my talk. We are hiring, and to see the open positions, please check out the link. Any questions, please feel free to reach out.
I wanted to introduce Stuart Kelly. Stuart is a senior engineer at Zego, there from the very beginning. Zego is one of the fastest growing insurtech businesses. So me and Francesco gonna leave, and it's over to you, Stuart.
Thanks, Power.
Cool.
Right, so I guess for anyone who doesn't know about Zego, I'll give a bit of a quick introduction. We've been going since middle of 2016, and really what the reason we exist is to provide cover that creates possibilities and changes the way people are able to go and work. We started by selling insurance to the gig economy at an hour a time, because if you were a delivery rider or an Uber Eats rider and you wanted to go and work for a couple of hours on a Friday, Saturday night, you couldn't. You had to go and buy an annual 24/7 insurance policy just to be allowed to work. And we said that doesn't make any sense. So we just decided to try and make insurance that really does make sense, and be a true disruptor, I guess, in the sense of the word. My role at Zego has changed many times in the last, what are we up to, 4 years now? But I'm currently a staff engineer. The role of a staff engineer at Zego is really to make sure that, like, on a very technical level, we are moving in a direction that gets us to where we want to be as a company on a longer horizon. So as a software engineer, day to day, it's very easy to get caught up in what is my ticket now? What is this one problem that I'm trying to solve today or this sprint? Or maybe every now and then you look at your current quarterly OKRs, and so you're looking sort of up to 3 months in advance. And it's very easy to go day by day and do the best thing every single day and still not be where you want to be in 18 months' time because you didn't realize you weren't on the right road. So as a staff engineer, myself and the rest of the staff engineering team are responsible for making sure that the way we go about solving problems on that day-to-day basis and for those tickets is aligning us with the wider company vision over the next sort of 18 months. And one of those visions is what I'm going to talk about today, which is telematics. So for those who don't know about telematics, It's basically getting all of your positional behavior, your driver behavior whilst you're actually driving. Traditionally, it was done with black boxes that you would install into cars. But the way society is moving, and certainly the way our customers are moving, people now have incredibly powerful computers sitting in their pocket the whole time while they're driving and while they're working, and that's their mobile phones. And these phones have got accelerometer data, they've got GPS data, they've got all the data that you need to be able to probably understand how somebody drives. And so what we wanted to do as a company was take that data that they have and empower them to understand how their driving will actually impact their risk profile, and then in turn what they pay for their insurance. So be able to feed back to people, you are driving really well, your insurance is likely to come down next time it's up for renewal. Or conversely, hey, listen, like you're really hard on your brakes, which not only is going to increase your fuel consumption, but also it's going to cause your insurance premiums to go up. And one of the things that we understand there is that data, especially in the current climate of privacy, that data is a currency. For people to share that data with us, they're giving up quite a lot. And so we want to be able to return that. And we return that in a number of ways. One, by offering like the flexible policies and the products that allow them to work. And two, by really being able to provide more value back to them. Everything from fuel consumption and wear and tear on their vehicle through to like, here is practical steps that you can do to reduce your insurance premiums. So this is not our first foray into telematics. We tried to do this back at the start of 2017. And at the time, there weren't very many app-based telematics companies. So we partnered with a more traditional black box provider who said, if you guys can collect the data on the phone and send it to us, we can do all of our processing to be able to turn that data into a driver score and understand exactly how they drive. At the time, our mobile apps were all based in React Native. And what that meant was that we were trying to collect what is very raw data from the guts of the different machines and process it in JavaScript and send it off to a server. And the reality was it wasn't good enough. It wasn't good enough for us to use to reliably tell someone how they were driving. And if we weren't going to be able to do that, then we couldn't provide that value. We could collect a whole bunch of data and it would be fantastic. But if we can't accurately assess someone's risk or accurately provide them with how that risk is going to change their insurance, then we weren't going to just drain people's batteries for the sake of it. So we shelved that product back in the end of 2017. I think it might have been December. And we ripped all the telematics out of our app and said, we're just going to put this on hold. We know that this is really important. We know that understanding how you drive is really important to our users, but the technology that we were using at the time wasn't good enough. So if we fast forward to this year, to today, when we decided that it was time to have another stab at this, we started to rewrite our apps in native code rather than React Native, which what that did was gave us better access to that raw data and allowed us to really start to collect it and process it on the device without chewing through people's batteries. And we were able to partner with very experienced app-based telematics companies. So using some of their core technologies, using their SDKs and plugging it into our app. And then what that gave us is not only the experience that they had got over the last couple of years from processing app-based data, but meant that rather than solving the challenges of how do we process that data on a phone and get that data to the server, we could start to solve the challenges that were more important to our users, which is how do we provide value then back to them? And some of this is in like pretty user interfaces. Some of this is in nice graphs and charts and scores and, the gamification of, you've got more points than your friend has got for that day. But also it comes into how do we start to use that data to actually affect your premium? For those who know much about insurance, you go to a comparison website, you fill in 50,000 different fields. They all go off and get priced in some archaic underwriting system, and you come back with what is really a proxy for your risk. One of the things that we believe that we can do by getting people's raw data and understanding the things that actually affect your real risk. So how much attention do you pay? How do you drive in different driving conditions? Rather than unconscious proxies or bias. So things like, what is your postcode? Do you live in a high income area or a low income area? These kind of things don't really have an impact in how good a driver. You can be an excellent driver, and the fact that you're 24 and you live in a low income area and you've only had your license for 4 years doesn't really impact your risk as much as the fact that we can tell by the way you're driving that you drive very carefully. Whenever it rains, you drop your speed limit by 10 miles an hour, which means you're much less likely to have an accident. And if you're less likely to have an accident, then we're not going to have to pay out as much in the way of claims, so we can reduce your premiums. And so that's where I guess we are going with the technology and why telematics is so important to us. The biggest technical challenges that we have with all of this stuff is literally the volumes of data. People talk about big data in lots of different sense, and we've got tables with close to 1 billion rows in them for different policies and transactions, but 1 billion rows in a Postgres table is not really even that big a data. Once you start getting into, we are taking data points 60 times a second from 50,000 users and publishing that all to a server, and we want to run machine learning models and analytics over that to be able to provide data back to people in real time, that's when we start to get into the really interesting and fun bits, which is a lot of the challenges that we're solving at the moment. So they become about moving data around, pipelining, warehousing that data, making it available to our data scientists to train their models, and then putting those models into production to actually use them for pricing. We use a number of technologies. Much like Tessian, we're a Python stack on AWS. So being Python really allows us to use the same technologies as our data scientists and our tech ops team. And so the entire stack all gets to utilize the same code bases, which is fun. It means we get to look at what other people are doing and really easily understand their code. But also means that we can interact and we can move around and help different teams. So what we're doing at the moment around this is making sure that we have the right engineers on the right teams and putting together these squads to be able to say, right, we've got a big push on food delivery. So COVID's obviously a very good example. The amount of drivers that Uber Eats and Deliveroo and Just Eat are onboarding at the moment is huge. So how can we really push towards getting those drivers the most amount of value from sharing that data with us? I've got no idea how I'm doing for time, by the way. I know we were running a little bit over late, but I basically just want to say that we very passionately believe in making sure that the data that people give us is something that we not only treat with respect and treat with all the security that this kind of very personal data deserves, but is also treated like a currency. And if people are going to provide it to us, we need to be able to give back to them that same value. And that is a challenge that Lawrence has just told me that I can keep running, so I can just keep talking. That is really a challenge that I thrive on, because at the end of the day, no matter what we're doing as software engineers, it's about providing real value to our users. And from day one, when our users turned around and said, like, thank you for existing, I wouldn't have been able to work if I couldn't buy my insurance in this by the hour, to these days where people are saying, hey, thanks for telling me how I'm driving. Like, I thought I was a really good driver, but I'm scoring middling to below average. And I can see, like, we give people the feedback in real time. And we can see people's driving behavior really start to change. And if that causes not only people's insurance premiums to go down, but also people to have less accidents so they can continue working for longer, then that's fantastic and a win for everybody. I want to say, like everybody else, we're hiring. I'm pretty certain that Samuel's going to post a link to our profile on my tech tree. We are hiring a lot of. Oh, hang on, I've got a question. Yes, I love Q&A. Do you see on-device AI as an opportunity to reduce data bandwidth? If so, how much of a problem do you foresee model optimization to be? Yes and no. I believe that there is quite a lot that can be done with it. One of the big issues we have is that it's going to be used a lot more for processing the data on the device, but still sending it off. We're not able to take just the accelerometer data and the GPS data and use that to update your price. There's a lot more factors that go into it, but being able to provide real-time interactions to the user specifically for what we consider first notice of loss. So one of the biggest challenges in insurance is, do you have a gap between when an accident or an incident occurred and when that gets reported to the insurance company? And the longer that gap between an incident is, the more expensive claims are going to be. So being able to process that data on the device to properly understand, hey, this was a harsh break or a large bump, or this was an accident. And like I said, provide value back to the user to say something along the lines of, hey, is everything all right? Do you need us to call out an ambulance? Have you just had an incident? Like, we have support staff on hand that can help you with this thing, because quite often people are in a state of shock. So being able to do that on-device processing and optimization for incident notification, I think is definitely there. Would you use federated computing, Google research paper to build global models on the device? It's not something we've looked into. It's something that I know our data scientists were talking about in Slack. I think the specific paper that you're talking about, but it's not something we do at the moment. I could definitely see it being something useful, but I don't know quite enough about it to comment.
Cool. And there's one more question from Andre. Do you see an opportunity for reinforcement learning algorithm in pricing at your company?
Yes.
Cool.
Yes. Very, very short answer. Yes. I think I'm getting kicked off.
You are, Stuart. You are very kindly, but that was a great presentation, and thanks the audience for some more questions. Stuart, I think you can continue to answer the questions to Andre or Frederick afterwards. So thanks a lot, and yeah, you guys, anyone in the audience, feel free to reach out to Stuart, and the next person to talk is gonna be James. Hello, James. Do you hear me?
Yes, I do. Can you hear me okay?
Yeah, absolutely. So, James gonna be speaking about Impala and their software, which is providing solutions to the sector that's very much impacted by coronavirus, the hotel industry. So, James, over to you.
Cool. So hi, my name's James. I'm from a company called Impala, and yes, as Powell mentioned, it's been a challenging time for the travel sector, for the hospitality and travel sector. So yeah, so it's been an interesting few months for us. So what is Impala? What do we do? So I've been here for about a bit over 2 years now, and I started off as a software engineer at Impala, and like the other startup I worked at before, I've done a sort of mix of platform engineering and software stuff, and so it's it's a different world doing platform stuff, I think, and really luckily I've been able to do a combination of that and then move directly into doing platform stuff full time. So if you have any questions about that sort of journey and that kind of side of things, then pop me a message on LinkedIn, and I'm happy to talk about that all the time. All day long, even. So when I first heard about Impala, I had this kind of question. I was like, why do we need to build an API for travel? And one thing that really resonated with me from Mofe's talk is the kind of world of open banking and that sort of access to data. And so I assumed that in many ways, the developer experience for a lot of industries or a lot of systems is really great these days. There's an API for everything. You know, if you want weather data, you want a map for something, look up an address somewhere. There's an API that exists for it. And so when I heard about Impala initially, I was like, well, why does Impala exist then? You know, do we like some kind of API gateway? You know, very, very similar to things we've just heard talked about. Moving things to a little bit of a different industry or different world, if you think about how easy is it to take payments online, it normally looks something like this. And apologies if your favorite language isn't featured. And really, businesses like Stripe have made an incredible developer experience for a very, very complicated world, like all the world of dealing with the actual issuing banks, the credit card processing, different credit card providers, that sort of stuff. It's a huge, huge load of complexity that sits there behind the scenes. But the experience for us as developers is super, super nice. And it's like, how long does it take to set something like that up? You know, maybe, oh, I don't know, if you're running at hackathon speed, probably a few hours, or very early stage startup speed, I should say. For a more experienced company, you're probably looking at a few days maybe to get the SDK in, set up an account, read through the docs, that sort of stuff. And it's really that easy. There's no horrible payment gateways that look like they're from the 90s. You don't have to install any hardware, and it's just really cheap and fast and easy to do. And so I thought, well, surely this is the case for travel stuff. And so it's like, well, how easy is it to build products that use hotel data, or maybe to sell stays at hotel, to sell bookings, or even something that seems very simple, like choosing a room when you book a hotel. And it turns out that a lot of that stuff is actually very difficult. And it's like, why is it so difficult? Why can you do this in many worlds, many industries, but you can't do it in the travel hospitality space? And the sort of reasoning behind that is that if you think about when you're booking a room for a hotel stay somewhere, for example, your experience as the person staying there might be very simple. It might just be logging onto the booking website, choosing a room, choosing the dates, whatever, and sorting it. But actually, how we arrive at, from the top of the diagram, the systems that are often running on premise at the hotel, through layers of complexity and layers of systems to you as the end user, really means that it's super, super hard to get that data. And there are some standards reminiscent of the sort of open banking world in this space, but they're definitely not incredibly well adopted. And many of these systems that hold all the really important data for those hotels are on premise. They don't change very often. You know, these are manual upgrades that are done by solutions engineers, once a year or once every 6 months. And it's not like there are 2 or 3 big players in this market that you can integrate with really easily. And you start to hear things like this, like, okay, well, yeah, we can add this connectivity in, but yeah, the project probably takes 6 months to implement. It's €500 a month for the connectivity. You've got to have a lot of face time with people like solutions engineers getting involved with it, support teams, and have a really, really long and slow implementation process. And the real kicker, something that seems kind of crazy these days, is that actually to get connectivity with these systems and to get access to this data, they've got to install more hardware on site because many of these systems are on premise. And if could you imagine turning up to a pitch meeting for a product with a hotel and saying, well, we've got this really great product that we'd like to use. And they say, okay, how do you connect it to our system? And they say, well, it'll take 6 months. It'll cost you €500 a month to run. And you've got to install a new server. It just, these days seems mad when there are so many SaaS products and so much of what we do and build is online. And the really frustrating thing, which is a killer in many scenarios, is that oftentimes you've got a great product idea for something you want to build for the travel world or for hospitality world, and you just can't do it because you just can't get the data you need to actually build that. And it's really not this experience. And so as a developer, for me, that was really exciting. It's like, wow, can we come into this space? Can we come into this world and make it this easy? Can we effectively power products that without us couldn't exist. And in the same way that at the moment, you could easily say, well, can you imagine having to do payments without Stripe? What I really want is that in a few years, you'll be able to say, well, can you imagine travel without Impala in the same sort of vein? So what have we actually been up to recently? So other than looking marvelous in some racing outfits, normally, because our developers have always been remote, we do a quarterly co-location week. So we go to all go to the same city in the UK normally, and we do various events and team building things and all that sort of stuff. But this year, obviously, is a little bit different, and so we've done a remote one instead, a remote location, as I'm told to call it. And part of that sort of remote location event is that we do a hackathon. And the hackathon is a really great way for us to try out some of our own products, do a bit of dog fooding, as it were, and also to try some experimental concepts that we maybe want to try as new things that could enrich the product from what we got already. So, for example, we had one team that was looking at reviews for hotels, and they said, well, if you take reviews for hotels as a data set, you do some natural language processing on them, can you then enrich the data that we provide as part of our products, perhaps by knowing certain things, being at a hotel, like does it have valet parking? Is it child friendly? That sort of stuff. And one thing that I referenced very briefly earlier, which is kind of like a big thing, is room selection. So if you imagine when you book a flight somewhere, there's always the option to choose your seat, and you pay a different amount of money based on where the seat is. And you might think, well, why on earth can't we have the same sort of thing for a hotel? Like, why can't I choose the one with a corner view, and maybe pay a little bit more? Or why can't I pay a little bit extra for the one that gets the sun in the morning? And if you think back to that diagram of all the layers of complexity between the sort of hotel systems that don't necessarily have APIs even, and you as the developer building products for that world, there's huge layers of stuff in the middle, and at each stage you lose data, and at each stage you lose the frequency of updates to that and the freshness. And so actually being able to go onto the standard hotel booking website you might use normally and to see a room plan with what's available is pretty much impossible. And it seems crazy that you can't do this. And so one of our teams recently was looking at combining the data from two APIs that we have. One to do with distribution, to do with selling rooms and selling bookings effectively. And the other one looking that's deeply integrated with these hotel systems, with the property management systems, and saying, well, could you combine the data from these two APIs that we've built to manage this experience, to make something where you could actually book a room, which from the outset seems really simple. Seems like something you should be able to do mega easily, but actually because of the complexity that exists in the industry, it's something that's really very hard. And we've got stuff like this. We had people talking about different models for consistency in databases, that sort of stuff. And really, I love the co-location weeks and miss deeply going and meeting people in person and actually doing these activities together. But yeah, it's a really nice way to look at the APIs and products that we build, look at that complex travel space that is, let's say, developer phobic, and try and make that easier to digest and easier to use, and hopefully power some really cool and interesting products that could make good use of that data. So yeah, so hopefully that was a little introduction into our world. Feel free to reach out either in the chat here or on LinkedIn for anything. And as the people will mention, you can find us on the TechTree website, or I think on directly on the jobs postings on Hopin itself. Thanks so much.
Thanks, James. A great presentation. Rosie comes from Lingumi, a very interesting company that's gonna help your kids to learn English. And I think this is it's quite interesting. From my own personal perspective, I remember that I started to learn English by playing computer games when I was 10, and then there was nothing like Lingumi. Currently, my 5-year-old daughter is an expert at correcting my pronunciation. So I guess I would have Lingumi available. I would be maybe more impressive for my own daughter when it comes to pronunciation. But Rosie is going to speak about the magic and technical details behind it. So over to you, Rosie.
On the landscape side is currently Unity games. So back when this was first turned into a mobile app rather than a physical app, the idea was that we would have this app full of Unity mini games that would allow the child to just learn English through playing games. We have since evolved, which is actually one of our main challenges that I'll talk about in a second. But I'll briefly just go over our tech stack. So as I said, we've got the React Native app. We're currently in the process of converting all of that into TypeScript to try and make it a little bit more reliable and make sure that we know everything will work at runtime. We then have the Unity part of that as well. And then on our back end, we write everything in Node.js using AWS and AWS China, making sure we make the most of their serverless technology, using DynamoDB and the API gateway stuff. And then we also have AliCloud for our global accelerator, which is what I'm going to go into a bit more detail on. One of the biggest challenges we have at Lingumi is the fact that the app has become popular in China. One of the most common places for children to want to learn English through our app is in mainland China. They have a different internet to us in the sense that they have the Great Firewall of China. This means that passing any sort of request through it is a lot slower than sending a request to any other country. It also means they block certain requests due to privacy and different data laws than us. So to get around this, we set up AliCloud and got a global accelerator through them, which allows us to pass through certain requests much quicker, as if we were doing them from within China themselves. One of our biggest examples of this is our main style of game is a voice recognition game. So the teacher will ask you what this is, and he'll be holding an apple, and then the child has to say, this is an apple. We then send that voice recording off to an API called Soapbox. They will give that recording a score based on how well the child's pronounced it. That's then returned to us, and then we'll then give that score to the child in a much nicer format. Originally, when this was set up, it just didn't work in China. The request times between Soapbox and the app in China were just far too slow for it to be usable, but the global accelerators helped us around that. We still have many challenges in China. We have different app stores, for example, so they don't use Google technology, so they don't have the Google Play Store, which means we are deploying to, I believe, 4 different app stores in total. And we have different apps for the global versus China. And we are trying our best to keep them unified, but while also allowing for the different countries. This is the same with our backend infrastructure. So we have AWS and AWS China, which, although our similar infrastructures, are obviously in 2 different places. One of our challenges we're working on is trying to make sure that we keep those unified and don't have to worry too much about deploying and managing 2 different infrastructures while making sure that they both work properly for both countries. The same comes with China when it comes to data. Obviously, they've got different data laws than we do in Europe, which is something we have to work with a lot when it comes to analytics. So we have data stored in different places for different apps. This is also true of our next big experiment, which is trying to put in A/B testing. A lot of people that make mobile apps would jump straight to something like Firebase testing, Firebase A/B testing. However, because that is a Google-based product, we're not able to do it. So one of our sort of quarterly objectives of one of the teams is sort of looking into it and trying to find a solution that will work for us and work for both the global app and the app for China. So our other major technical challenge and bugbear at the moment is Unity. Unity is great in itself. If you're making a game, it's wonderful. But when you're trying to make an app that isn't just a game, it becomes a bit much. The fact that we're running a full game engine in our app has very much bloated it. It's made it quite large that we don't want. And it's also caused some difficulties with deploys. A month or a few months ago, Apple and Unity were having a disagreement around some privacy rules and some terms that meant that Apple stopped people from deploying apps that had any Unity in them. This meant that we weren't able to actually deploy our app for a little while. Our initial solution was that we've set up code push now. So we're actually able to push JavaScript changes up to the app and have users download them without actually having to do an app store reinstall, which is very good for the short term and also will be good for us to use in the background. However, isn't a long-term solution. If Apple were to ever completely ban Unity, we wouldn't be able to deploy our app again, and that would just cause us a lot of pain. So we've recently been investigating different styles of games that we can do, both to build new content and new courses, but also to eventually replace the courses we've already written in Unity. One of the ones that we've recently deployed to our users and seems to be working very well, we've aptly named Smart Conversations. Essentially, there's a video of a teacher who will make conversation with the child. The child will then respond. Based on the response, the child will then see a different video. If they've said it correctly, they'll get a well done and either another question or telling them it's the end of the session. If they don't say it quite right, they then will be asked to say it again. And if they can't say it again, they'll get sort of more and more hints to help them say it correctly in the end. And this is the sort of direction we're heading now. Alongside that, hopefully within the next month or so, we're looking at having some sort of internal hackathon with our engineers to try and help us discover some more options we might have for games within the app. So we're sort of going to look at, can we make super basic games like purely using React Native and just like buttons? Like, will those be interactive for children, or are there other React Native game engines out there? How can we do animations in interesting ways? We've got quite a lot to explore still. So I think I will wrap it up there. I just want to say thank you for listening. We have a couple of open roles for full stack software engineers. So you can either head over to the website I've linked or to TechTree itself. Feel free to get in touch with myself as well if you have any questions. Thank you.
Thanks a lot, Rosie. Like I really enjoyed listening to it, and I think I would definitely love my amazing 5-year-old daughter to listen to presentations like that at some point. She's very into computers, as is my son, and I think the careers in tech are in a way future-proof. So it was great to have you, and I don't see any questions, but if anyone has any questions, please reach out to Rosie directly. You can do it via LinkedIn or still on the platform here. But that's going to be it for today. So I hope everyone enjoyed. One last thing I wanted to say is again that as TechTree, one of our goals is to enable engineers from all over the world to get access to top engineering roles as well as mentoring. And again, if you're interested in mentoring, in being mentored, on mentoring other engineers, let us know. And also, I wanted to thank Francesco and Silicon Roundabout for being a partner on this one, and LocalGlobe and Emma Phillips, who kindly supported that whole process and kickstarted it. And we're going to have several events in the coming months with portfolio companies of North Zone, EQT Ventures, and the Fund VC. So I hope we're going to meet again. And thanks a lot for a great midday time, and looking forward to seeing you all again.